Today, we are taking a deep dive into the medical evolution of schizophrenia treatments.
Yeah, and it is a really fascinating journey.
It really is. We are solving this wild mystery of why one patient might take like 2 milligrams of a drug, while another needs 800 milligrams to do the exact same job.
We are actually dissecting a very detailed, hand-drawn medical map today that charts the whole course of antipsychotics.
And the illustrations are great.
They are. It illustrates this transition from using a rather blunt instrument to tuning a highly complex system in the brain.
Exactly. Our mission here is to demystify that jump from the first generation of these medications to the second. We want to know how they physically work for you and, well, why those dosage numbers look so drastically different depending on the prescription.
So let's start by looking at the left side of the diagram, the first generation, or what they call typical antipsychotics. These basically act as strict dopamine blockers.
Okay, dopamine blockers.
Yeah. What is fascinating here is they specifically target what is called the D2 receptor in the brain.
Right, so let's unpack this for the listener. If schizophrenia involves overactive dopamine, which is, the chemical driving things like hallucinations, these first-generation drugs are basically like putting in heavy-duty earplugs.
I like that.
You are just blocking out the loud bass. Like, the dopamine is still floating around, but the D2 docking station is completely covered up, so the chemical key just can't connect.
A very effective acoustic barrier, to use your analogy. Yeah. But even with that straightforward blocking mechanism, the amount of raw material required is wildly inconsistent.
It really is. I mean, looking at the data here, a drug like Haloperidol only needs a tiny, 1 to 5 milligrams a day to start doing its job, and maybe maxes out at 20.
Right, a very small footprint.
But then you look at Chlorpromazine, which is doing the exact same blocking, and it requires starting at 50 to 100 milligrams, and it maxes out at a massive 600 milligrams.
Which naturally forces the question, right? If putting in earplugs to block the dopamine base works to manage symptoms, why did researchers go back to the drawing board to invent a second generation of drugs at all?
Well, because just blocking the base wasn't a perfect fix. The music still sounded off.
Exactly. The strategy had to shift from simply blocking to something much more nuanced. So we move to the right side of the diagram, the second generation, or atypical drugs.
The balancers.
Yes. These act as dopamine plus serotonin balancers. They interact with that D2 receptor, but simultaneously target the 5-HT2A receptor, which handles serotonin.
Okay, so instead of just earplugs, they're acting more like an equalizer on a mixing board, balancing both the bass and the treble at the same time to get a really clean sound.
That dual receptor interaction is literally the defining breakthrough of this generation.
But here's where it gets really interesting, because the dosages here make even less sense than the first generation.
Oh, absolutely. They are all over the place.
You have got Risperidone doing this delicate balancing act at just 1 to 2 milligrams a day, up to maybe 8 max. But then there is Quetiapine, which takes up to a staggering 800 milligrams a day to do the exact same thing.
It sounds crazy.
Yeah, like if they both use the same equalizer strategy, Quetiapine must just be physically weaker or something?
Well, no.